I welcome all the students of TIT for this video lecture of Theory of Computation. Myself, Sejal Rati, and I'm from IT department. In this video, we will go through the types of finite automata. So there are two types of finite automata. This is a finite automata, and there is a two types of finite automata. First one is a deterministic finite automata, that's a DFA, and the second one is the NFA, that's a non-deterministic finite automata. So now what is the difference between DFA and the NFA? So in the NFA stands for the non-deterministic finite automata and DFA stands for the deterministic. But now for every input symbol, there can be a more than one state transition in the NFA. In NFA, for every input symbol, there can be a more than one state transition. And in the DFA, for every input symbol, suppose we are taking the zero input symbol, there can be only one state. Suppose we will go through the example after this, then we will conclude that. So this then the NFA can use empty string transition, that's the epsilon. In NFA, we can use the epsilon, that's for the empty string transition. But in DFA, there is we can't use the epsilon for the empty string transition. There is no empty string transition in the deterministic finite automata. Then the NFA is very simple. NFA is simple, but the construction of DFA is little bit difficult. So now the construction of DFA. The finite automata is called deterministic finite automata if there is only one path for specific input from current state to next state. Then how? Okay, we will go through this. Suppose this is a S0 state. From S0 state, only one input symbol we are passing to the S2. We can't pass here again A. From this, in the DFA, from the S0, we can't pass to the A to the S2 as well as S1. In the DFA, we have to give only one input string. That's A or B. From this state, so for input A, if there is only one path going to S2. Similarly, from S0, there is only one path for input B going to the S2. So there is only one state to which an automaton can transit from the current state on each input. The word finite implies that number of states are finite. A finite automata consists 5 parts. Now, which 5 parts? First one is state, that's a tuples. The first one is states. Second one is input symbol or alphabets. Third one is initial state. Fourth one is final state. And fifth one is transition path or transition mapping. These are the 5 tuples. So the two parameters are passed to the transition function. So one is current state and another is the input symbol. The transition function returns a state which can be called next state. A transition function returns a state which can called next state. For example, suppose for Q1 equal to delta of Q0A. That means what it means? So it means that from the state Q0, with the input A, the next state transition is, the next state transition is Q1. Correct? What is here? What the meaning of this? Q1 equal to delta Q0 A. What is the meaning of this? The meaning is Q1 is a next state. Q1 is next. What? Next state. Now, what is Q0? Q0? Q0 is state, previous state. Okay? State. And what is a? It is a input. Correct? It is a input. So that means from the state Q0 with the input A, the next state is Q1. Correct? So in short, the DFA is a 5-tuple notation denoted as Q, sigma, delta, Q0 and final. So here the name of DFA is A. Here the name of DFA is A. Correct? And you can take any name, whatever name you want. You can take the name of the DFA is M or N or O, whatever you want.